Radical as an exponent. Radicals as exponents. The nth root of a equals a raised to the power of 1 over n. Notice the radicand a under the radical will be the base when written as an exponent. The other thing you notice is the index n will always be the denominator when it's written as a fraction. For example 1, it says rewrite as an exponent. For a, we have the cubed root of 7. Notice 7 is your radicand. That will become your base. The 3 is your index. That will become your denominator. So the result will be 7 raised to the power of 1/3. For b, we have the square root of 11. Notice 11 is your radicand. That will now become your base. Your index of 2 will now become the denominator in the fraction. So your result is 11 raised to the power of 1/2. For c, we have negative square root 23. The result will be negative 23 raised to the power of 1/2. Example 2. Rewrite as a radical and simplify if possible. A, we have 25 raised to the power of 1 over 2. In this case, they gave us the problem in exponent form, and we have to rewrite it as a radical. So we start by identifying our base, which is 25, which now will become our radicand. Next, we look at our denominator, 2, which will become our index. So we rewrite this as the square root of 25. Since the problem asked us to simplify, we need to try to expand this and pull out any sets if we can. For 25, we know that it consists of 5 times 5. And since our index says we need 2 of the same thing, we notice we do have a set. So the 5's come out of the radical, and your final answer would be 5. For b, we have 27 raised to the power of 1/3. Notice 27 will now become your radicand, and the 3 in the denominator will now become your index. So we rewrite it as the cubed root of 27. Again, because we're asked to simplify, we need to expand the 27 by doing the factor tree. And you should find the cube root of 3 times 3 times 3. According to the index, we need 3 of the same thing to complete a set, and we do have a set. So we pull out 3's, and your final answer will be a 3. For c, we have negative 9 raised to the power of 1 over 2. Notice that negative is out in front, so we deal with that part later. 9 will become your radicand, and your index will be a 2. So we currently have the negative square root of 9, and we need to factor the 9 into 3 times 3. Notice we do have a complete set, so the 3 comes out, and your final answer will be negative 3. Let's look at another rule. A raised to the power of m over n is the same thing as the nth root of a raised all to a power of m, or the nth root of a raised to the power of m. I know this can look a bit confusing, but notice the n is in the denominator, will always be your index. Let's look at example 3. Rewrite as a radical and simplify if possible. For a, we have 4 raised to the power of 3 over 2. Notice 4 is your base. That will become your radicand, the part under the radical. and then start with the denominator. Your denominator is a 2, which will become your index. So let's rewrite it as the square root of 4, all raised to the power of 3. We're following order of operations, or GEMS, so let's focus inside the parentheses. And since we have the square root of 4, let's expand that and see what we really have. 4 is the same thing as 2 times 2. According to the index, we do need a pair of 2's, which means the 2 comes out of the radical, but it is still inside the parentheses. Now that we have simplified what's inside the grouping symbol, we move on with GEMS and we have our exponents. 2 to the third means 2 times 2 times 2, which we know results in an 8, and that would be your simplified answer. For B, we have negative 16 raised to the power of 3 over 4. So first, we notice what's going to be our radicand. Now my question is, does the exponent affect the negative sign? And the answer is no. That negative stays outside, far in front, because the exponent is only touching the 16. So we write it as negative, parenthesis, the fourth root of 16, all raised to the power of 3. We focus inside the grouping symbol, and notice we have that radical, so let's expand 16. 16 is really made up of 2 times 2 times 2 times 2. According to the index, we need 4 to complete a set, and we do have a set. So we simplify. Notice we still have the negative in front. Inside the grouping symbol, we have our 2, but our exponent is still on the outside. Now, according to order of operations, what comes next? Multiplication or exponents? Well, exponents, which means we write this as negative, still waiting out in front. And then the exponent is 2 times 2 times 2. So our final simplified answer would be negative 8. For problem C, we have 27 raised to the 2/3 power. This is your try it problem. Okay, let's see how you did. You should have rewritten it as the cubed root of 27, all raised to the power of 2, expanded 27 in factored form, found a set of 3's, did your exponents, and your final answer should be 9.